Hey everybody, this is Mr. Beckstrom, and today I wanted to talk about the SLO quiz, and I made some review questions that are going to be similar to some of the questions that you see on the SLO quiz. So let's go ahead and get started. You're going to have 5 questions, and they're going to be similar to these, so just make sure you understand how we work these. The first one here, we're either going to be multiplying two exponent numbers or dividing them. So when you multiply two numbers that have the same base, and they can have any exponents they want, what you do is you combine the bases together. So you combine the bases together, and then you're going to add those two exponents together. So 5 plus a negative 8 here. So it's going to look like this. Basically, you're going to use the same base, that as long as they're the same, use the same base, and you're going to add the two exponents together. So this is going to simplify to 10 to the 5 plus negative 8 is negative 3. And that'll be your answer. And when you divide, you do almost the same thing, except for adding, you subtracting. And you put the top number first, and then the bottom number second. So in this case, 10 raised to the top number goes first, 10 minus the bottom number goes second, 12. And 10 minus 12 is negative 2, so this becomes 10 raised to the negative 2 power. And both of these can either be written like that, or you can write them, you can put the base underneath the quotient line and make the exponent positive. So this would become 1 over 10 cubed, and this one would become 1 over 10 squared. I think the quiz wants you to put it in with the negative exponents, but if they don't, then try it that way. All right, the Greenland ice sheet contains about 3 million cubic kilometers of ice. If completely melted, this would release about 4.6 million kilometers of water, cubic kilometers, which would spread out over Earth's approximate 340 million square kilometers of ocean surface. How much would the sea level rise? So this is a pretty tricky, probably the trickiest question out of all of these. And here's how we have to think about it. Let's say we had some sheet of oil over the Earth's ocean surface, and this is going to kind of have a height to it, right? And what we want to do is we want to figure out what is this height right here? What is that height? So how much did it rise off of the surface? And when we find the volume of any shape like this, we could always write it as the base, the area of the base of that item, times its height is equal to its volume, right? So if we find the area of the sheet here, and we multiply it by its height right here, the small little height, that's going to give us our volume. And since we're trying to find this height, because we want to know how much it's raised, we can divide both sides by the base, and I'm going to get height is equal to the volume of the entire thing all over the area of the base, because I just divided both sides by b here. So this is what we're solving for. So the height in this case is equal to, well, the total volume that's released, and remember, volume is always going to be in like a cubic number, right? So it's this 4.6 cubic kilometers. So I'm going to put 4.6 on the top, because that's what my volume is. And then the area of the base, that would be like the two-dimensional area. So we're looking for something that has square in it, or to the second power. And that's right here, the 340 million square kilometers. So I would put that down here. Now, since they're both in millions, I don't have to write them all out. I could just use these numbers. If one of them was in millions and the other one was in thousands, then you would have to convert to the same or just use the entire numbers. But in this case, they're both in millions, so I'm just going to be using just the first parts of those numbers there. And then all we're going to do is divide that. So 4.6 divided by 340. And that's going to give us an amount of, if we go out to 3 decimal places, that's 0.014. The 3 goes up to a 4 because the number to the right of it is 5 or higher. So this is 0.014. Let me just double check that. Yep. And so this here would be the answer. And this is kilometers because the problem is in kilometers. So it would rise 0.014 kilometers, which would be about 4 meters. I'm sorry, it would be about 14 meters. Yes, because you could just move the decimal place 3 to the right, convert that to meters, but it's not asking that. But that would give you an idea of how much it would rise. All right, number 3. How much must be deposited today into the following account in order to have $200,000 college fund in 16 years? Assume no additional deposits are made. All right, so this is from section 4B here, and the formula for that looks like this. A is equal to P times 1 plus APR all over N raised to the NY. And then we really have to know what each one of these things are. So A is our total amount or our future value. P is the principal, that's the amount that we deposit. The APR is the percentage rate in decimal form. The N is the number of times per year that we're compounding. And then the Y is the number of years. So in this case, A would be equal to the principal, that's the amount that we deposit, 200,000, times 1 plus our APR in decimal form. So in order to change this from percent to decimal, we move the decimal place 2 to the left. So this would be 0.052 all over N. That's the number of times that we compound each year. So this says quarterly. Quarterly means 4 times a year, so we put a 4 underneath here. If it was done monthly, there's 12 months in a year, so that would be 12. If it was done daily, there's 365 days in a year, so that would be 365. And then raised to the power of the N times Y. So we already know N, that's 4. It's always going to be the same numbers down here. Times Y, that's the number of years, and this is 16 years here. All right, so I can put all of this into my calculator here. Pretty much just like it is right there. So if I go to my calculator, which you should have one, and put 200,000, open parentheses, 1 plus 0.052, you don't always need to put the 0 in front, but you can if you want to, of the decimal place, divided by 4, close parentheses, raised to the 4 times 16. And I just put it in all just like it is there, and hit enter. And so this is how much we would have after 16 years. $457,125 if we round it to the nearest dollar. If we round it to the nearest cent, it would be 124.50. All right. All right, off to the 4th problem here. And it says, what is the probability of tossing a coin and getting either a tails or 2 tails? Well, one way I can answer this is by doing what's called a sample space, and that's where I list all the possible ways that I can flip 2 coins. So I'm going to call this a sample space, just SS for short. And I can get no heads, right? Or if we do it in the terms of tails, I can get the first one, or let's do each coin separately. So the first one could be a tails, the second one could be a tails. The first one could be a tails, the second one could be a heads. The first one could be a heads, and the second one could be a heads. The first one can be a heads, and the second one could be a tails. So these are all the possible ways that I could flip two coins here, and all. So I could either get both heads, both tails, the first tails, the second heads, or the first heads and the second tails. There's no other way that I could flip two coins, no other outcomes. So the next thing I want to do is see how many are listed here. Well, it says either that should be one tail, right? So if it's one tail, this one includes just one tail, and this one includes just one tail. And the other one, or two tails, and this one includes two tails. Therefore, the probability of getting one of those results would be 3 out of 4. So I can just write that as 3 over 4. So I have a 3/4 or 75% chance to get either one tail or both tails. The only time that I don't get one of those results is if I flip both heads, and there's only a 1 in 4 chance that I do that. All right, I hope that helps with that one, and let's take a look at this last one. So the last one says, in designing a new home entertainment center, there's a choice of 4 different TVs, 5 different amplifiers, and 3 different speaker sets. How many different systems can be designed? Well, this uses the multiplication property for probability, which basically says that if I'm combining different things together, what I can do is I can just multiply those. So there are 4 different ways for TVs. So that means if we're just picking a TV, I have four different possible ways to do that. I have 5 possible ways to pick an amplifier, and I have 3 possible ways to pick a speaker. So to find out the total number of ways I can pick all 3 of those, I just multiply the 3 numbers together, and that's going to give me 60. So in this case, there's 60 ways to pick these 3 different items. And that's it. So make sure that you take the SLO quiz by the due date, and if you have any questions, let me know. Thanks.